This is a lecture about solving quadratic equations, and we introduced the three different methods of solving quadratic equation. The first one is called factoring, and the second method is called the method of completing the square, and thirdly we use this formula called quadratic formulas. There are two kinds of example in the factoring. This is the first example and slightly simpler than the second one. So before we factor, let's understand how two polynomials, product of linear polynomials, are expanded. So if you have x plus 2 and x plus 3, how do we extend this polynomial and simplify? So raise it a little bit. It turns out if you write these two factors vertically, it's easier to see, and it really helps us to factor later on. So I wrote it up here like this: x plus 2, underneath it x plus 3. When you multiply out, what happened is that all these individual terms in this factor and that factor, they're multiplied to each other, all listed out. So we have two terms here, and we have two terms in the second factor. So these two terms and two terms they're all paired up. So there are four possible pairing. So they're written up here like this. First, we're going to multiply x to x. So that's going to give you x squared. Next part, we're going to multiply this 2 and 3, and that's going to give us a 6. Next part is that we can pair up this 2 and x and 3. And that is going to give us this part, 2x and then x times 3. That's going to give you 3. So these two things are in this kind of same term, so we can combine it into simplify 5x. So that's why we have, if you multiply these two, we're going to simplify it into x squared plus 5x plus 6. So that's how you actually expand the product of two polynomials. Factoring is the backward process. They give you this simplified version of the polynomial, ask you to figure out these two linear factors. The strategy is that you look at the 6 and think about where the 6 came from. 6 came from multiplying these two constants of this linear factor we're asked to figure out. And think about where the 5 came from. 5 really came from this 2 plus 3. That's exactly sum of these two numbers involved in this shape of linear factors. So this is always so. If you have x minus a and x minus b, then this number will be a times b, and this number will be always the sum of these two numbers. So strategy go like this. If you don't know what those are, we think about all factorization of 6 and see if some of those factors, 2 and 3 for example, see if they add up to 5. So that's a strategy. So let me use an example to explain this. So here's an example. For example, suppose we're solving x squared plus 5x equals 24. To use this factoring method, make sure you have the 0 on the one side, so you have to subtract both sides by 24. So you have this equation, x squared plus 5x minus 24. After you factor these polynomials, if you don't have right-hand side at 0, you don't have much of a conclusion. If the product, this is going to be a product of these two linear factors we try to figure out. If there's 0, we have a good conclusion. This is either 0 or that the other factor must be 0. But if it is not 0, then we don't have a definite conclusion about what this number should be. So make sure you have this 0 in that side. So our goal is that this x squared plus 5x negative 24 can be written as this vertically like this, as a product of two linear factors. So when we do all the multiplications, it's supposed to become this polynomial. And our strategy was that these two numbers are supposed to multiply to negative 24, and if you add this two number, it's supposed to be a positive 5. So not knowing the answer, I will just try some simple factorization. So negative 24, how can we write this negative 24 as a product of two numbers? There's a silly way. For example, negative 1 times 24. Right? That's a product of these two numbers becomes negative 24. And this, if you write this negative 1 and 24 here, the sum of these two numbers is supposed to be the coefficient of x in here. But if you split this negative 24 in this way, sum of these two numbers is 23, and it is not equal to 5. So this factorization, if you put it in there, you're not going to match that 5. So you have to think about all the other possibilities. There are many, if the number is big, and there's many ways of doing that. So in that case, it's not going to be very efficient. This factoring method works nicely when the involved coefficients are fairly small. If not, we have to use the next method called completing the square method. So now from here, you have to consider all those possibilities, negative 24, product of negative 24, and you have choices of putting where you put this negative in here. If this were positive 24, then you have a choice of putting negative in here, which is easy to forget to consider. But if there's negative, it's easy. You got to put the negative somewhere. It could go there, and it could go there. But if turns out to be the correct pair, 8 and negative 3. That's product is negative 24. If you add these two numbers, it becomes 5, and that's what you see there. So you have to try a couple times. As you practice more and more, you have a better sense to figure out this correct pair. So this 8 and negative 3 goes here and there. So it's in red here, 8 and negative 3. And you can actually multiply out just like we did it before, and you can see this simplifies to this. So once you figure this one out, solving equation is fairly simple. So here's the rest of the part. So this polynomial x squared plus 5x minus 24 is identically equal to the product of these two linear x plus 8 and x minus 3. So these product equals 0. So because two quantities of product is 0, either of this factor must be 0. So that's why we have a definite conclusion. If this is 1, for example, on the left-hand side, you can't say this is 1, 1, or negative 1 and negative 1. There are many other possibilities, such as half times 2, and that's going to be still 1. So you don't have a smaller list of a conclusion here. But here we have x plus 8 being 0, x minus 3 being 0. That must be happening, and that's the only case where this product of two numbers becoming 0. So that's written here, x plus 8 becoming 0, that corresponds to x equals negative 8. X minus 3 becoming 0, that corresponds to x equals 3. And especially because of the 0, what we have here is that this is it. That's the definite conclusion. If this is not 1, you can set it to 1 and whatever you want. You get a numbers, but that's not, these two things have to be satisfied at the same time. So it's not going to happen. And this is, if one thing is 0, and no matter what the other one is 0, it's going to be 0. So we have these two numbers, and especially these are the only two numbers in the real line that makes this quadratic polynomial exactly 0. So let's take a look at the second kind of factoring problem. The difference between this problem and the earlier problem is that if you look at these two linear factors, there is some non-trivial coefficient in front of x. Before it was x plus something, but here now we have 2 and 4 in front of it. So if you look at how this one is being expanded, how it unfolds, it also helps us to figure out how to factor if you have a quadratic polynomial whose factorization looks like this. So let's expand this. The method is the same. We're going to vertically write these two linear factors, 2x plus 3 and 4x plus 5, and we have to multiply out everything just like we did before. Like before, if we multiply these two, we have 8x squared. If we multiply these two, we get 15. Now, we also have to multiply all the other possibilities, namely this cross multiplication, 3 and 4, and 2 and 5. From there, we have 12x from this 3 and 4, and 2 and 5, we get 10x. So together, it's a 22x. So they simplify to this polynomial right here. So 8x squared plus 22x and 15. So suppose you're given this polynomial, 8x squared plus 22 plus 15, and they ask you to figure out what the two linear factor is. Then what you have to do at this time is not only we deal with this 15, you have to deal with this 8 too. So 8, think about how these two number factors, 8 factors into two numbers, how is the 15 factored into two numbers. Then when you do the cross multiplication, they should come out exactly 22. So it involves a little bit more of a case checking, a little bit more of errors you have to go through. Let's look at examples. Right, here's an example. 2x squared plus 7x plus 3. You see, a coefficient of x squared is not equal to 1, so we have to figure out linear factor in this more general form. Not just x plus something, we have to deal with these two more numbers. So I copy down that polynomial, 2x squared plus 7x plus 3. So we have to think about how to split this 2 in here, and how to split 3 in here as a product of two numbers. And again, although these 2 and 3 are positive numbers, you also always have to consider the case -1 times -3. -1 times -2, they as a product is actually 3 too. So I copy those 4 boxes down here to practice, and think about how to write this 2 as a product of two things, just like 1 and 2, and 3 a product of two things. These 1 and 2 are called prime numbers, so there are not many ways to write as a product of two things. So checking process here is not going to be that bad. But you can imagine if these two numbers, 2 and 3, instead of 2 and 3, numbers with a lot of factors, it requires a fairly good amount of checking here. So I just wrote down a 1 and 2. Think about the possibility of 1 and 3. Could be 1, 3 here, or -1 and -3. So to some of you it may look silly, but I'll try those examples. Okay, so wrote it in there, 1 and 3, so its product of 1 and 3, it is 3, so that fits in. So let's see what happened if you cross multiply, and they're supposed to be equal to 7. This product of these two things matches 2. Product of these two things matches 3. So what about the cross multiplication? They're supposed to match exactly this 7, because that's the way these two polynomials expand. So it shook a little bit, sorry about that. If you do that, we have 2, and if you do that, it's a 3. If you add these two numbers, we don't get 7. Right? So this combination doesn't work. Right, I did another silly thing. What about -1 and -3? So they product of these two things becomes +3. So when I tried, only thing that changes the sign is -2. That part is -3. So altogether it becomes -5. That's still not 7. So you have to check like this, keep changing, and this time the order matters. You can swap this 3 and 1, then what is being multiplied is different, so you should try different orders as well. So here it turns out the right combination. If you swap this 1 and 3, we have 3 and 1 here. If you multiply these two, you get 6, and that get 1. So as it's written down here, you get 7, and that's the coefficient. So that should go 1, 3 here, and 2, 1. So if you put 1 and 3 and 2 and 1 there, if you do the 3 and 2, that's 6 plus 1, that fits exactly to that. So that's the factorization. So the last bit goes like this. I wrote it horizontally, x plus 3, that's one of the factor, and 2x plus 1 is another factor. You write it like this, and from here it's the same. Set the first factor equal to 0, second factor equal to here is a 0. From there we have these two numbers, and that's how you solve this problem. Thanks.